continents have been drifting over the surface of our planet for most of the past 4.5 billion years. Lonely pieces of land surrounded by crashing waves on all sides. During rare occasions in Earth history, however, these cratonic blocks were called to come together. As if a giant magnet was suddenly switched on, the landmass's paths suddenly converged. It's during such a continental reunion where our geological story of southern Libya begins. Numerous continents, cratonic fragments and island arcs were on the move. Eventually they collided during the so-called Pan-African orogeny to give birth to the legendary southern megacontinent of Gondwana. Gondwana was the united South America, Africa, India, Australia and Antarctica. Two large cratonic blocks dominated the area at the time that today is North Africa. The West African Craton and the East Saharan Craton. When these two cratons crashed into each other, a large Pan-African collisional zone developed between them, the Trans-Saharan Megabelt. Some authors say the Western Murzuq got caught up in this collision, while the Eastern Murzuq laid on the stable East Saharan Craton. And also the present-day Kufra Basin was rather safely positioned on this block. East of Kufra, however, another war zone erupted. Series of island arcs were thrown against the East Saharan Craton and were accreted. The resulting East African orogen is more than 2,000 kilometers wide and extends over Egypt and the Arabian Peninsula. Never again since these times have continents collided so close to southern Libya. The rocks preserved from this phase come from the deep. Formed several kilometers beneath the Earth's surface, they speak of high temperatures and enormous pressures. Banded and strongly recrystallized metamorphic rocks, plutonic granites. The crystalline basement of southern Libya. A basement which is of Neo-Proterozoic age in the Pan-African mobile belts, but which can be much older on the cratons. The Precambrian basement comes to surface in several places around the Murzuq and Kufra basins. A good area to study the Pan-African action of the region is the Hogar Massif in neighbouring Algeria, which is part of the Pan-African Trans-Saharan Megabelt. Here, the structural fabric of the central North African basement is revealed. A fabric that also extends into the subsurface of southern Libya and forms the basis for much of the later structuration. The Hogar's Precambrian basement is disrupted by deep-reaching vertical shear zones that generally trend in north-south directions. These shear zones often represent the former terrain boundaries of the small continental fragments involved in the Pan-African collision. Wounds in the Saharan body which never healed again until today.
Prior to the Cambrian and Precambrian, the structural lineations were mostly broad and north-south. So at that time, most of the sedimentary basins were not created.
Ever since, every little pushing and tilting has caused southern Libya and Algeria pain along these reactivated old zones of weakness. Depending on stress directions, the land was pushed up or down, intraplate transpression and transtension.